In this illustration, it is given a projectile is launched at angle theta naught. This projectile is launched with velocity v naught, that is the initial velocity of the projectile is v naught, and it is projected at angle theta naught. At the highest point of its path, that means at this position, it explodes into two parts of the masses of ratio 1:3. The lighter part retraces its path. Find the velocity of the heavier part just after explosion. Okay, this is the problem. Now let us analyze the situation. This projectile is projected with initial velocity v naught at angle theta naught. We know in case of the projectile, the horizontal component of the velocity remain constant always. That means at the highest point, the velocity of the projectile should be equal to v naught cos theta naught. Okay, so let us make the diagram for this situation. Initially, this particle just before explosion should have the velocity v naught cos theta naught, right? M is the mass of the projectile. Now what happened? At this point, it exploded into two parts. The ratio of the masses is 1:3. Let us assume mass of the lighter part is m naught and mass of the heavier part is 3m naught. That means m naught should be equal to m/4 and heavier mass 3m naught should be equal to 3m/4. Let us assume initially these are having the mass m naught and 3m naught. Okay, so the lighter mass of mass m naught retrace its path. That means the velocity of this lighter part should be equal to velocity of the projectile at the highest point, highest position. We know the velocity at the highest position is v naught cos theta naught. That means velocity of the lighter part just after explosion should be equal to v naught cos theta naught, but in the leftward direction. Now let us analyze the heavier part. Heavier part is having mass say 3m naught. This velocity is unknown, so we can assume the unknown direction is in the rightward direction, and let us consider this velocity is having magnitude v. So this is the situation just after explosion. Okay, and we know at the topmost point, if we consider this object as a system, in the horizontal direction there is no external force acting on the system, right? That means the linear momentum of the system should be conserved. Linear momentum just before explosion and just after explosion should be equal. So let us write the linear momentum of the projectile just before explosion, and let us consider this direction as a positive direction, rightward direction. So linear momentum just before explosion should be equal to m multiplied by v naught cos theta naught. This is the P initial. Now let us write the linear momentum of the system of the particle. Now we have two particles just after explosion. This is equal to minus m naught multiplied by v naught cos theta naught plus 3m naught multiplied by v. V is unknown. Okay, and we know this value is m/4 and this value is 3m/4. So let us apply the conservation of linear momentum of the system of the particles just before and just after explosion. This linear momentum should be equal to this linear momentum. So let us conserve the linear momentum principle in the horizontal direction. This is the initial linear momentum just before explosion. This is a linear momentum just after explosion. So let us substitute the masses m/4 and 3m/4. You can observe this m and this m will get cancelled. Now we can find the value. This is equal to 3/4v and this is equal to 1/4 v naught cos theta naught, and this is v naught cos theta naught. That means we can write 3/4v equal to 5/4 v naught cos theta naught. Okay. Now we can get the value of v from this equation. So let us write the value of the velocity of the heavier particle just after collision is 5/3 v naught cos theta naught. This is the required value.
Dear aspirants, Cengage India has launched the new edition of our JEE Advanced Physics books. Please visit www.cengage.co.in to buy a copy. You can also buy the books from Amazon or Flipkart.